So here we talk about subroutines and user-defined functions. So subroutines are the user-defined functions used to perform specific action. This is one of the fundamental layer of the code reusability. They are chunk of code written and can be used any number of times. And the advantage of using subroutine includes modularity, adaptability, flexible, generic, and parameterized. So this means if we want to call a code which performs a specific action, and that code we want to reuse throughout the program, so it is called code reusability, and it increases the functionality of the code because we don't need to write that thing again and again, and we can just use that reusable code. So the syntax is subroutine, and here the thing is like subroutine, like how a subroutine is defined. So the syntax is sub for subroutine, name of the subroutine, and inside this parenthesis the statements. So what statements you want to have in the subroutine. So sub is the reserved keyword used to define subroutine. Statements can be any number of statements. So let's go to the next slide and see. So let's open this slide. So I think it's subroutines. Okay, this is the same program. So let's go to the want array. I think the name of the program is wantarray.pl. So see what it does is, okay. Oh no, this is not the program. Okay, let's go through this. I'm not sure what is the name of this program. So here what we do is, example of a subroutine is, we do sub hello. Okay, so name like C or C++, we will always have a subroutine with like open and closing brackets. So these are like, it has no arguments. So you can also have functions or subroutines having some arguments, and you cannot have you can have without arguments. So this is without arguments, and opening and closing parenthesis, that is the start and end of the function. So this is actually the definition of a function or subroutine, and it is always prepended with sub space subroutine name. So that's how subroutine is written. So defining a subroutine hello, again it will override the first definition. So if we do this hello, so this is another user defined function. So in Perl, it will not give you an error if it is defined again. So it will just override the definition of the subroutine. Now call the subroutines in the following way: hello. So if we call hello, when we pass the parameters, normally we use this when we pass the parameters of the subroutine. So at the rate of hello and hello, it exclusively look user defined function. Now we can just see, I think that what is the name of the function we need to see. Hello. Okay, let's go through this functionality. So it is very much clear. So here we do sub print. So first subroutine, and print A is bit confusing, and we call print. So also again understand that we can call a subroutine or a function with the subroutine name and open and closes braces, or we can also pass at the rate and subroutine name. That is also correct. It's not an error, because a function will have an address. A function or subroutine will have an address. So so you can also call by calling the address and the name of the subroutine, or you can directly call the subroutine. So here we do print, and print, this is the predefined function call, right? So so it looks for a user defined function. And next is defining a subroutine hello. So first we call hello, and again we call hello, and we pass another argument, and then excuse me. So we call hello first, and then again at the rate of hello, and we can see what is the output, right? So let's see subdemo.pl, what is the output. Okay, so first it prints a bit confusing because that is the first print statement. Next we call at the rate of print, and then we again print a different statement. So it is a predefined function call. So that means the definition is got changed completely by the next invocation of the print. So this is allowed in Perl, but this is not allowed in C or C++, where it will give a redefinition error. So here what you are doing is you are calling, you can define a function, and you can override the meaning of the function or the subroutine completely by redefining it. So the second is printing. This is another predefined function. And next what we do is sub hello, print hello. So here we have to call this subroutine. So this is called a definition. So definition is like we have the sub function subroutine name, open and close brackets, and the open and close parenthesis and some value. And then again we are calling hello and this thing, and we have to call this explicitly. As you can see that here we have done the print, and here we are calling the print. So okay, so we are calling this print. So why it is confusing in the first case is here this print is a user, it's not a user defined subroutine, it's a subroutine which is system specified. So you want to print a statement, so you call print, but the subroutine name is print. Here you are calling print. Okay, so you are calling print. So first, let me explain this once more. It is actually not changing the definition of this. I think there was another example of changing the definition of this, but what we are doing here is we are just invoking this function, invoking this subroutine. So we are defining this subroutine here. You can see that we are invoking this subroutine in these two lines. Okay, we are defining the subroutine in these two lines, and we are invoking it in this line. So when we invoke this subroutine, right? So we can directly remove this ampersand, or we can also print put this ampersand. Doesn't matter. We do this. It will call this subprint, and it will print this bit confusing. And then this print, the next print is actually the print command or print subroutine from the standard library. So this print function will give you the actual predefined function. So actually you can see this, the name of the print is also a function. This print is also a function, but the name is same. But this is a user defined print function, while this print is a system defined print function. So this is predefined functionality which is defined by the library. So first it prints this, and next it prints this line. Again here we define hello, and again we define hello. Okay, we override the meaning of hello. So when we call hello first, okay, so it prints prints the first hello. So it prints, this is another user defined function. So this is another user defined function. So again we call at the rate of hello, and so see here. Okay, now see what is the difference. So here we are printing, we are putting the definition of hello. So if you see these lines, okay, if you see these lines, we are having a definition of hello, which is like print the first user defined function. But did we see this anywhere in the output? We never saw this in the output. The reason being, we are redefining the function, and when we redefine this subroutine, I'll rather say subroutine because this is the term used in Perl. So this will completely override the meaning of this previous hello, and whenever you call hello, so you are calling hello 3 times in 3 different ways. You are calling HELLO, or you are calling at the ampersand HELLO. So if you are just passing the name, so you need not have the open and close brace. And you can also pass at ampersand HELLO and open and close brace. So it will always give you the second hello. So it will print the second statement. So that's how it is. So let's see the next slide. Okay. So want array. So this is the same thing. I don't think this is the functionality of want array, because want array is a different functionality. Sometimes there are some small mistakes in the slides. So if something is there, we can rectify it. So this is a different program altogether. So let's go to the next slide. So we are done with, and we have another 10-11 slides to cover. So hopefully we will be on time today. So the best way to call. So subprint. Okay. So hello. I hope you guys are able to hear me. No issues, right? So I'll continue. So subprint and print a bit confusing, and again we call. Okay, fine, great. So I'll continue. So subprint, print a bit confusing. So first we have this subroutine, and we have this definition of subroutine where we just print a bit confusing. And next we call @print. Okay, so that is a invocation of the functionality or invocation of the subroutine. So it will just look for user-defined function. This is simple because this print, whatever we do, this will be user-defined function and not the actual print command which is used to print a statement, normally like print and something. So this will be always user-defined, and user-defined will have priority over the system-defined print. So if you print this, okay, so it will always print you the user-defined functionality. So note, please avoid creating the same name. User-defined function will conflict with the predefined function. So we can also do Perl sub2.pl. So here also you can see that it is always invoking the user-defined function rather than the predefined function, that is print, because this print command, you can see that it is the next line. It is in the next line where we just print some statement, some string. But previously we are calling the print functionality, but it will take the previous print. So the next print. So that's how we should understand. So how it works out is, in any programming language or any object-oriented programming languages, based on the arguments and the return types, the function overloading is done. So if you talk about C++, there is some concept of overloading wherein based on the arguments, based on the return types, the name can be same, but you can have different arguments. You can have integer and float. It will be doing some other functionalities. So that's called function overloading. You can think of this as a function overloaded case wherein though print is already defined, you are overloading the print, and here you are passing some argument in the print, which is some string. But here you are not passing any argument. So it's like a function overloading. But it is little different in Perl when you compare to normal high-level programming languages like C or C++. So let's go to the next one. So return value from subroutine. So when the subroutine encountered with the return keyword, it immediately returns the value to the main program without executing the further statements in the subroutine. So that is very much important. As I said, exit. So when exit comes out of the entire program. So when we call exit one, okay, so how it works out is, if if we open the previous thing like sub2.pl, and if we call here exit1, okay, and this is sub2. Okay, so see the output. You can clearly see the output where it exits from the entire program and it doesn't execute anything below, right? So you can also pass this within the brackets. Okay, it has the same meaning. It is similar to C, wherein we can either pass exit1 or exit0, and you can pass within brackets or without brackets. Or there is something called exit0 as well. So if you do exit0, you can see what is the output. So it is the same thing. So these are some exit codes which are passed to the OS, okay, which are passed to the OS, and it can be 0 or 1. But when you call exit, it comes out of the entire program. But if you call return, okay, if you just call excuse me, if you just call return1, okay, as per the slide here, okay, so it okay, so it's okay. This return is different from the subroutine return. Here they are talking about a return from a subroutine, but we can also do return1. Let's see what happens. See, cannot return outside a subroutine at sub2.pl, right? So you can clearly understand that what is the basic meaning of a return and what is the basic meaning of exit and how they are different. So return is basically used for subroutine. Okay, so you can say that used for subroutine. Right? But when you do exit, it can be called anywhere in the program and it will exit out of the program. So generally exit one is called at the end of the program so that it can come out gracefully, so that other statements are executed. But return, when it does, so it will be completely returning from the subroutine. It will not execute the next programs in the subroutine. So that is the error. You can clearly see what is the difference. So it will say that cannot return outside the subroutine. But if now if you execute, it will execute fine because we have commented. So that's the thing. So again, you can see that you can return scalar, array, hashes also from the subroutine. So you can understand that it's very much similar to a C or C++ kind of return, where the return can be an int, char, float normally, but you can also make the function to return a pointer. You can also make the function to return some address or something. Similarly, in Perl, you can make the subroutine to return a scalar, array, or hashes also from the subroutine instead of just some value. So again, context comes into account when you return different data types and capture in different data type. So we'll talk about this in the next slide. So you can see this example, sub3.pl. So let's open sub3.pl. So you can see, so what does it do? We are passing two arguments, that is the 0th argument to num and first argument to power, wherein in the command line you already know that argv is used to pass arguments in command line, and each argument will be passed, will be captured in argv. It's like an array, and the number of arguments will be completely stored in the argv array or vector. So what we do is $result equal to get power. So we want to get the power and again print result. So what here we do is get underscore power, return $number start $power. Now you can see that $num is the argument 0 and argument 0 and $power is the argument 1. So if we are passing two arguments, the first one is the number and the second one is the power, and the statement will never get executed. The reason being, see, we are calling get power and print result, and here we are calling subroutine get power. Okay, so why it will never get executed? The reason being, see, this is not defined early before this. So here we are calling get forward, but get power is not defined here. Understand what is the thing. So sub 3. Okay, let's see. Okay, so here actually it supports the subroutine outside like below the actual invocation. So here we are calling get power, but normally in a procedure oriented programming we should always have this function definition before making the invocation. So but Perl allows it. Perl has this flexibility, you can put it anywhere. So it is actually taking the get power and we are putting, but in other things we must define this first, and then we can call this get power. Okay, otherwise it will give you not defined error or something in C. But Perl gives you this flexibility where you can define it anywhere below also. So when we talk about C and C++, we tell that it's like a procedure oriented programming. It's like a top-down. It's like a top-down approach where one function calls other, one function calls other. So we have to first define, and it will have call some other function. But C++ is like objects. It's at the end. Object is at the end. You can call everything earlier. But in Perl, it is like it has the entire flexibility to define it anywhere, because it is a one single program. So you can call and you will be able to see the output irrespective of where it is defined, at the top or at the bottom, it doesn't matter. So the output here we can see that we are passing 1, 3. So we can pass 6, 2, and we get 36. So it is like we are passing two arguments. The first one exponential is the second one. Okay, and we are just passing nothing. So it is just it is expecting nothing is getting passed. So it will be just one in the sense that we are like it will be initialized to 1, and it will be taking like there is only one argument, and that is like 1. So how it works is like normally the executable, whenever we are passing this sub3.pl, this is the argument. We can call this as the sometimes it's called the default argument. Like we are having one argument, that is the executable name. So this is one argument we are passing. It's not like 0 argument. So it will take that single argument and it is going to pass this as 1, and the dollar power also we are having 0. So it is like it is also like it will not be 0. It is also initialized to 1. So it will be like 1 to the power 1. So it is 1. But normally you should make it more logical. So you should not pass anything and it will give you some jump results. You should rather pass something which is relevant. So here you can get a to the power b. So let's go to the next slide. So want array. So want array is also, we can say that it is also a keyword, and it is also a function, additional function in Perl, which is set to true if the context of the currently executing subroutine is looking for a list value, and want array is set to false if the context of the current executing subroutine is looking for a scalar value, right? So if it is expecting a scalar value, it will be false. If it is a list value, it is true. So if you are if you are talking about a list like an array or hash, and in that context it will give you true, otherwise it will give you a false for a scalar. So you can see this program wherein we have this array and we pass this in pass this in a scalar. So LH is an array, LH is a scalar in the second case, and print $b. So we are passing the array in what we do is that this is called a reference. So we are passing the reference of I'm sorry, this is a print statement. So we want to just print. So here it is not a reference. Here it is just overriding the special meaning of @. So it will just print @ of b is equal to @b. So it will print @ of b and the value of b. That is whatever is here. And here it is like dollar. We want to override the meaning of dollar. So we pass $. So it will be like $C is equal to C. So here the C value will be printed. Now this one array is used in test automation exclusively, wherein we want to see if the data coming from a router or some hardware device, it gives a scalar value or it gives a list value. So we are testing the output and we want to print that hello to the one array demo, and we are passing the array and return array if one array. So here it is like a list. So it will one array will return 2, and if it is not true, it will return scalar expected. So let's now execute this one array function program. Okay, so you can see the test this, and we are passing this thing, and you can the output. We can just see what is the output. Okay, so here hello to the one array demo. So first it prints hello to the one array demo, and next what it does is hello to the one array demo again. Okay, so hello to the one array demo. So demo and b is equal to 1237 $series scalar expected. Okay, so let's see the output because okay. So see, in this case, what is happening is we are executing this program and we are first getting hello to the one array demo and return array if one array is true. So it will return the array, entire array, that is the entire elements of the array if one array is true. So again, one array is actually true because the input is a list, not a. Next thing is what it prints is like here we are printing. You can see that here we are printing $b. So here we are printing b is equal to $b. So here first case it is an array, so it prints, and in the second case we are passing c, which is a scalar. Okay, in the second case it is a scalar. So in the second case it will also go to this one array function. So what it is used for testing basically. One array functionality is used for testing. So you can see in the first case, it's if we are printing it twice. Why we are printing it twice? Because we are going to this subroutine, right? We are going to this subroutine, and the first time when what we print is the first test WA. So here it will go to this test A. Test WA, and it will execute this functionality wherein it will say that hello to the one array, and it is an array, so it will print. Second case, what it will do is here it is we are passing a scalar. We are passing a scalar. So in this second case, it will also print hello one array demo. But in the second case, we are getting a scalar, so it will immediately say that the array it will not get, and it will say scalar expected. That's why we see this output twice. One array demo, and we see first time we are getting the array and second time we are getting a scalar expected. So let's go to the next slide. Sorry guys, I'm again little late. I'll try to quickly cover all the other slides. Other 6 slides we have, 7 slides. So pass the arguments. So Perl places the arguments to a subroutine in the special array called @ underscore. So we had this $_ as a special variable which stores the default argument, and @ is a special variable which stores the arguments of the subroutine. So we can do and then underscore, and we can pass what are the arguments to a subroutine which we talked. So it's actually not $_1 which I talked, it is actually @_1 for subroutine arguments. So where we were. Okay, so there are two ways to pass the arguments. One is pass by value and pass by reference. Pass by value is you are passing the direct value. Pass by reference is like you are passing the address basically. So how we pass the address is we are using the ampersand operator. So we can pass the address if we use the ampersand operator. So it will pass the address of that location, and we can swap. So basically it will be used in swap and all functionalities, where if you just swap it and if you do call by value, it will be only swapping locally. So if you are wanting to swap 10 and 20 and you are just passing by value, and here also you swap it, then it will not be swapped outside because you are only swapping the values. But if you swap by reference, then what do you pass the pointers? So what will happen is the pointers will get interchanged. So 10 will become 20 and 20 will become 10. In that case, once you call back, return to the actual function, so it will get the actual values. So that is one important way where we will use call by reference, wherein we want to do some operation. So we will be doing call by reference and we will be passing the thing to the call function. So here we are adding, instead of swapping, we are adding two numbers. So you can see that how we are adding. We are passing the reference of add. So $add, what we do is $var and $var2. So 10 and 20 we do, and in add, what we do is $add equal to default add. So we are passing this the arguments of the this function to this. So here we need not call by reference, because here this is actually not calling by reference. This is actually calling the function itself, calling the subroutine itself. But calling by references will be here. That is the parameters. So here if we pass the address, so it will be called by reference, but here we are calling by value only. But the good thing is this is a default argument array. So we need not pass call by reference and do. Instead, we can use these special variables, and it will already store the values, arguments of this subroutine, and it will be passed. So when we want to do an add, and we do $equal to $b, so this will pass on this argument 10 and 20, and when we return, it will just add 10 and 20, and it will give you the result. So that's it. So let's go to the next slide. So pass arguments by reference. So here we are passing the reference. So if you are passing by reference in Perl, in actually C it is ampersand, but in Perl, if you want to pass a reference, it is like the backslash and the name. And this is not overriding, because in the print statement, if you put within the double quotes and then you put this backslash, it is overriding. But in this case, it is the reference of that array. So reference of that array means it is the address of the array. So when you want to concatenate, or you want to concatenate two arrays, how do we do that? So what we do is we are passing two arrays as for concatenation. 10, 20, 30, 40. So when we concatenate array 1, it will be 10, 20, and concatenate array 2, it will be 30, 40. Okay. So again, when we want to do concatenate $a$b, return $a$b. So this is how we dereference an array reference. So we can just execute this program and see what is the output. Okay, so it is like 10, 20, 30, 40. So here what we are doing is we are returning the at the rate and $a and at the rate of $b. Means what we are doing is we are concatenating the array and we are passing this into a you can say it's dereferencing. Dereferencing means you are converting from the reference to the actual array. So when we have a reference and you want to dereference it, then you have to call $@ or $$ is also okay, right? So when we do, it will give the values of A and values of B. So values of A is 10, 20, values of B is 30, 40. So this is about it. So let's see this. What is the output of the following code snippet? Number 1 equal to 10, number 2 equal to 20, print demo function number 1. So return shift at the rate of underscore. So what will happen is we are passing 10, 20 and we are print demo number 1. So we are passing 10. Print demo and number 1. So first we are passing 10 and return shift. So shift what it does is shift will add, right? And unshift will remove from the starting of the array. So here when we do a shift then what it does is it will pass 10. So shift function will pull the first element from the array. Here there is default. The default array is at the rate of underscore. So it will be passed on, and that is what the result is. So let's go to the next functionality. So AUTOLOAD functionality. So there are a lot of functions. You have to just remember everything. You might not remember, but it depends on your script, what you are writing. So it might not be that much essential. So AUTOLOAD function, AUTOLOAD any calls to undefined subroutines. This is called so for exceptional handling. This AUTOLOAD functionality is used. The name of the missing subroutine is accessible within the subroutine and as $AUTOLOAD. So if there is some exception happening, then that will be automatically passed to $AUTOLOAD, and the arguments are passed to at the rate of underscore, which is same as like functionality. So any subroutine, any calls to undefined subroutines will be passed on to the AUTOLOAD function, and the parameters of this will be populated to at the rate of underscore. So here you can see this AUTOLOAD functionality. When we want to print this, you can see that AUTOLOAD at the rate of underscore. I've never heard of a subroutine called AUTOLOAD. I'm ignoring your arguments. So you are passing 3 to. I'm ignoring your arguments for me. So the simple thing is here in AUTOLOAD we are passing undefined subroutines. So that means we don't want to define those subroutines. So and these arguments are passing in $_ means the default the arguments of this functionality or the subroutine is passed in $_. Now we want to print the subroutine and $AUTOLOAD. So $AUTOLOAD, what it contains? Okay, $AUTOLOAD doesn't contain anything actually because it is undefined this thing, and I am ignoring your arguments. So what it does is when we are adding 3 and 2. So I'm saying I'm ignoring your arguments 3 and 2. Okay, and I have never heard of an argument. I have never heard of a subroutine named main multiplying. I'm ignoring your arguments 4 and 5. So what it does is whenever you pass these arguments to an AUTOLOAD, so you can see that this adding functionality and multiplying functionality is never defined. That is the thing. So AUTOLOAD will contain those functionality arguments. So adding, we have seen that we have not defined this argument. We are just invoking. Here multiplying, we are just invoking, but there is no definition of adding. So AUTOLOAD will automatically contain these arguments. The first time when we are passing this adding, automatically AUTOLOAD takes this argument 3, 2, and it says that adding, the name of the functionality will be passed in $AUTOLOAD, and the arguments will be at the rate of args. Okay, so we have like argv is like argument vector, args is like the arguments. So the arguments will be in the args, like at the rate of args. So like here we are passing the default arguments of this functionality to args. So this args will be printing you the arguments. So you can see that it will do the same thing for both the cases, adding and multiplying.